So how we're going to solve a system by using matrices instead of using the system itself? Well, what we're going to do is the following. First of all, we're going to apply elementary row operations to the augmented matrix. Remember the three elementary operations? Well, they apply in the same way to matrices. That means we can switch to rows. Remember, rows correspond to equations. Or we can multiply a row by a non-zero scalar, or we can add to a row a multiple of another row. So we're going to apply these elementary row operations until the solution appears. How to do that? Hold on to your hat. We'll look into that. Now, in terms of the notation, when we're applying these elementary row operations, we're going to indicate them as follows. If we're switching two rows, we're going to denote that in this way. So row I is switched with row J, where I and J are two numbers. So say row 1 is switched with row 3, or whatever the case might be. If we're multiplying a row by a non-zero scalar, we're going to indicate that by k times the corresponding row. And if we're adding to a row a multiple of another row, we're indicating by saying, okay, to row I add k times row j. So the row that needs to be changed is written first. Now, there are some people, some textbooks, some teachers, and so on, who will use actually a different way to write that operation down. Namely, they will write the row to be changed as last. Okay, now that's okay as long as we understand each other, and as long as this kind of notation is consistent and so on. So you can use either one of those two notations as usual. You have freedom of notation. However, I will be using the first notation all the time. I prefer to first indicate which row I'm changing and then write down how I'm changing it. So first row I, that's the one that we're changing, and then add to it a multiple of row j. Some more terminology before we see an example. We're going to do plenty of examples in class, but I want to fix a little bit more terminology here. Okay, so first of all, remember we called that matrix that we constructed, that object, that bunch of numbers suspended between those square brackets, the augmented matrix. Where does that come from? Well, what we can do is we can follow exactly the same kind of construction, but by using only the coefficients. Okay, so what we can do is we can construct a matrix. That means an ordered array where each row contains the coefficients of each corresponding equation, and each column contains the coefficients of the corresponding variable. Okay, and if we add to this then the constants, the column of constants, then we get our augmented matrix. Well, the technical term to say we're adding something to the object we already have is augmenting, and that's why we call this matrix the augmented matrix. Okay? Now, we shall soon generalize this idea of a matrix to other uses. Okay, so we're using this matrix simply as a convenient notation to solve linear systems. But it turns out that we can use matrices for lots more things than that. Okay, and that, in fact, is going to take most of the rest of the course.